To understand the step function improvement Zero delivers, you can start by thinking of something like a GPU versus CPU. The GPU has given us a roughly 20x improvement over Moore's law in just the past decade alone. That 20x improvement has created the entire graphics industry, all of parallelized computation, and the entirety of artificial intelligence. And that's just a single breakthrough. Charlie Munger from Berkshire Hathaway used to describe multiple 10x improvements compounding towards the same idea as a Lollapalooza effect. Zero is built on 4 100x improvements, 3 100x improvements across storage, compute, and network, and an additional end-to-end 100x improvement in ZK. Let's go through each one.
One of the problems with scaling blockchains is that eventually you run into a physical storage bottleneck. Verifiable databases use a data structure that saturates the drive with unnecessary writes, and the drive can no longer keep up. We set out to build a database that uses a data structure optimized for modern hardware and added verifiability on top. The result is QMDB, the fastest verifiable database in the world. It's 92% theoretically optimal and can perform 3 million updates per second. That's 100 times faster than the state-of-the-art verifiable database. Once we built QMDB, we realized the ceiling for what was possible was so much higher than we thought. The next thing to tackle was compute. And so we set out to build a scheduling algorithm that optimizes for maximum throughput in any VM. We call it FAFO, or Fast Ahead of Formation Optimization. It enables Zero to perform 2,500 times faster than BNB Chain and 50,000 times faster than Ethereum. Zero's heterogeneous architecture is enabled by next-gen ZK that proves with fewer calculations and a simpler interface. Jolt Pro delivers unparalleled performance to the ZK VM. It delivers an end-to-end 100x improvement over existing ZK VMs.
We spent a long time searching for the right ZK technology. We met with every team in the space, but everybody was only focused on solving Ethereum in real time, which is only 15 transactions per second. Nobody had really set their sights higher until we found Jolt. When we first met Justin Thaler and Michael Zhu, they'd begun working on Jolt out of the A16Z research lab and were developing it as an open source public good. When we reviewed their work, it was extremely clear that this is what was needed for ZK to actually scale long-term. We've had the chance to work with legendary partners and advisors like Dan Bonnet and countless others, building on the original work created by Justin, Michael, and the A16Z research team.
Jolt has been a contrarian bet from the start in the sense that it's a totally different set of techniques than what everyone was doing when we put out the Jolt paper. But I had full conviction personally that it was absolutely the right way to do it. The community at large was kind of not receptive to the message we had been trying to deliver for 18 months. I think just by coincidence, Brian and Raz were in town. And then we had this conversation. It was like suddenly people, I was talking to people who saw the world clearly in the same way that we did. It was like a meeting of the minds, and just everything took off very quickly from that meeting. There's been a lot of theater, people sort of pretending the performance is there when it's not, just obfuscated benchmarks or playing games with security so you can't actually deploy this stuff. That's led us to make all of the right decisions for the long haul, not cut any corners. This has been an inevitability to me from the start, and especially for all of the last year, right? Now, I think the only thing that sort of could have gone wrong was it might have been we just never found layer 0.
With these 3 unlocks under our belt, the last to solve for was the network. Jolt makes it so validators don't need to replay transactions, which also means they don't need to download them. They only need a transaction commitment, a proof that transactions actually exist. We created a specialized VID algorithm that delivers these commitments at scale. We call it SVID, Scalable Verifiable Information Dispersal. It delivers 100 times more throughput than IDMBA.
The culmination of all of this is one of the largest technological step functions our industry has ever seen. These 100x improvements compound to create an entirely new architecture, and like most compounding effects, the result is greater than the sum of its parts. For the first time, decentralization is finally possible at scale.